Okay, so in this video, we're going to go over 4.2, which is trig functions defined on a unit circle. When we're using a unit circle, we're going to say, well, the radius is going to be 1. So here, what we're doing is we're going to determine if a point lies on the unit circle. I already drew a picture here of a right triangle, and it's basically the same thing that we're going to talk about. If you remember Pythagorean's identity, it says a squared plus b squared equals c squared. In this particular case, I'm going to go ahead and put that here. A squared plus b squared equals c squared. This is Pythagorean's identity. In this case, the a squared is the distance of x, so we're just saying x squared. In this case, b squared would be the distance here, which is y, so we say y squared. And because the radius of this circle is 1, we would just say 1 squared, but 1 squared is just 1. So that's how we come up with this formula by using Pythagorean's identity. Okay, so how do we show if this point is on the unit circle? Well, we're just going to plug it into the formula, so into the equation. So negative square root of 3 over 2 squared plus 1/2 squared. Does that equal 1? If the answer is yes, then this point lies on the unit circle. So negative times negative is positive. The square root of 3 squared, remember, it cancels out, so we have 3. And 2 squared is 4, so we have 3/4 plus 1/4. Well, 3/4 plus 1/4 is 1, which does, in fact, equal 1. So we can say, yes, this point lies on the unit circle. Okay, so that's all we're going to be doing. We're going to be talking about and recreating the actual unit circle itself, which is really good information, and it's probably one of the things that most student tells me is the most helpful. All right, so if we continue through here, this part is basically talking about your points. So we have various points on the graph. Here, t is equal to 0. Here's our point. T is equal to pi over 4. If you go back to our unit circle here, remember we talked about the radians. If this is 0 radians, here is pi. So all I'm going to do is nicely cut up the circle. Well, what's half of pi? Okay, that's 90 degrees. That would be right in the middle here. All I'm doing is saying, what's half of pi over 2? Well, that would be pi over 4. This angle here is exactly the same as the angle here. Okay, so all you're doing is essentially cutting up the pi accordingly. And that's what we're doing here. We're saying that t is 0, here's the half pi, and over here we're going to get 1 full pi. When you go down, remember the down direction, that's when we use the negative. Okay, so this angle, even though it's the same distance, the same angle, the direction is saying this is positive going up, this is negative, you're going to go down. Okay, so all of those points are on here. We're going to go ahead and look at these sections here, and I actually like to go through this at another point, but we're going to go ahead and talk about it here. So this sine t is equal to y. Well, let's talk about that. If you remember your SOHCAHTOA, I'm going to go ahead and put that here. SOHCAHTOA. That's what we're using to identify all these specific points. So let's go back to sine. Sine t is equal to y. Well, sine, that's it's sine is equal to opposite over hypotenuse. So here I can say sine of theta is equal to opposite over hypotenuse. Well, if we're using a right triangle, and we'll go back to the one up here, and we have an angle here, what is opposite? Opposite's going to be the y. So here we can say y. What is a hypotenuse? Well, the hypotenuse is going to be the radius, and in this case, on a unit circle, the radius is always going to be 1. So this is going to be sine of theta is equal to y. That's why instead of it looking at it as it does here, saying x, y, we can look at it as saying this is our x, this is our y. So sine of t, or in sine of theta, you can use either one, is equal to in this case y. This only applies to the unit circle. Let's look at cosine. Cosine theta is adjacent over hypotenuse. Well, what's adjacent? Adjacent, here's our angle. Adjacent's next to. So this is going to be opposite, adjacent, and the longest length is always your hypotenuse. So adjacent is going to be x, and our hypotenuse is still going to be 1. So here I'm looking at cosine theta is equal to x, which is what I have here. So these can be translated completely. If we go through the remaining ones, which is tangent, opposite over adjacent. So let's go back to opposite. Opposite's going to be y. Adjacent will be x. Y over x. All of these are going to be your reciprocals. Okay, so if I decided to say 1 over sine, that's going to be the same thing as cosecant. Okay, so all I'm going to do, if I flip this one, if I say over 1, I can put this over 1 too. So I can basically say 1 over sine is equal to 1 over y. So 1 over sine is the same thing as saying cosecant equals to 1 over y. Same thing here. 1 over cosine is the same thing as secant, 1 over x. Okay, so this is the same thing as 1 over cosine t. Okay, this is the same thing as 1 over tangent. We're going to see this actually a lot as we go through. The denominator, in this case y, x, and y again, they cannot be equals to 0. Because remember, anytime you have a 0 in the denominator, that means it's an undefined answer. So this applies for this too. These two will not apply because, remember, the denominator is 1. So it will never not apply. Okay, so these could be all real numbers, essentially. These other 4 have restrictions. We're going to talk about that a little bit later as we go. Okay, so here, if a point lies on the y-axis, which is this point here or this point here, then x is equal to 0. Because remember, x's go forward or go back. Well, if it's here, it's going to be 0. But y can be a +1 or a -1. So that's where they come up with these 2 points. When x equals 0, tangent and secant are undefined. Okay, if it's on the x-axis, that means y is equal to 0, because remember, you're going forward 1 or back 1, but you're not going up or down. So then y would equal 0. If y is equal to 0, then your cosecant and your cotangent functions are now undefined. These are major things that you have to keep your knowledge of and keep on the top of your head, because we're going to be using that a lot and you will be tested on that a lot. Okay, let's go on to the next page. All right, here it says, now we're going to suppose that the real numbers t correspond to a point. Here's a point on the unit circle. Evaluate. Now we're just going to evaluate. So this is the part that I actually like to do a lot, and I'm going to show you how to do it. So remember, this is your x, this is your y. This can also be referred to as your cosine. So what I can do here is say cosine of t equals 5/13. Okay, t is going to represent your angle. This is representing your ratio. But remember, cosine, if you go back, that means, I'm going to go ahead and put it here, SOHCAHTOA. Okay, that means that the 5 is what we call it our adjacent, and the 13 is going to be our hypotenuse. So this is going to be our adjacent, or in other words, the x value. And the 13 is going to be your hypotenuse, or in this case, our radius. Okay, so that's what we're saying about this one. Over here, remember, this one is going to be sine. So I can say sine of t is equal to -12 over 13. Now, in this particular case, the negative is always going to be assigned to the x or the y. Never is it going to be assigned to the hypotenuse. And the reason for that is when you square a number, it's always going to be positive. So our hypotenuse is always going to be positive. So those negatives and positive signs have to be assigned to the numerators, at least for sine and cosine. When we get to tangent, we'll talk about that, because remember, tangent does not include your radius or your hypotenuse at all. It has an x or a y, and there you actually have to assign it to your x value or your y value, not to both. Sine is going to be opposite over hypotenuse. Our opposite, and I'm going to go ahead and do it like that, opposite or our y value. The bottom is going to still be the h or the r, okay? So if we're looking at sine, we can say, well, sine is already given. So the sine of t is going to be equal to the exact y ratio, which is negative 12 over 13. Cosine is going to be our x value, which is 5 over 13. So these are really easy ones. But this is what I like about the tangent one. Tangent t, now if we go back, we're going to say, oh, it's opposite over adjacent. Opposite over adjacent. Remember, opposite is going to be our y. Adjacent is going to be our x. But if I'm looking at these values, I can say, well, this is my y. This is my x. Now, notice that these two are actual ratios, and I could technically do that. I could say, well, let me put the y first, so it'll be negative 12 over 13, and then I can put 5 over 13. But then what we have right here is a really nasty complex fraction. If you don't know how to deal with fractions, I'm going to go ahead and do one for you, this one for you, and then I'm going to show you a shortcut. So here it will be stay, so the numerator stays exactly the same. This division bar will change into a multiplication, and then this one would be flip. So it's stay, change, flip. 13 over 5. Now, when you multiply fractions, remember you can cancel them out. You are not looking for a common denominator. That's only for adding and subtracting. So these cancel out. So once you notice that these cancel out and it applies to everything, it will always apply to everything as long as these are exactly the same. So when I'm looking at tangent, I don't really have to look at the denominators because I'll know that they'll cancel out. All I have to do is look at the numerators. So negative 12 is my y value, and then your 5 is your x value. So essentially, I can just look at it and say negative 12 over 5. That's what tangent t is going to be. If you learn this little trick now, your life for the rest of the semester will be so much easier. Okay, next part. Here it's saying, let p of x be some point on the unit circle associated with a real value. Of course, t has to be greater than or equal to 0. Okay, we're also going to let theta be greater than or equal to 0 and be the central angle in a standard position, which is, remember I told you, anywhere between 0 and 360. Okay, so here's all the information. Okay, so we're basically doing the exact same thing, but now what we're doing here is we're saying this is going to be in a standard position or standard angle, and this is not. Okay, so now we have negative values. All right, so be careful with this part here because s is still going to be a distance. It's always going to be positive, but your negative theta is going to be dependent on which quadrant we're in. Okay, we're going to talk a lot more about this actually in just a little bit, but this again is just the information that we're going to cover right now. Trig functions of real numbers are angles. Okay, so sine t and sine theta, those are going to be the same. These are going to be the same. Everything here you can see are equal to exactly the same thing. Okay, let's look at an example where we have a negative theta and a positive theta. Okay, so here we're going to determine several special values of t corresponding to the angles of multiples. So here we have 3 different thetas. Okay. By orienting the right triangle within the coordinate system. So let's go ahead and do the first one. All right, so here's the first one. Okay, this one is using pi over 4. If you notice pi over 4, what you're basically saying is that these two are going to be exactly the same values, because here pi over 4, if you go back to your angle, you'll see that that is actually a 45-degree triangle. So that's where we start with an isosceles triangles. Okay, so I'm going to go ahead and just show you and refresh your memory on that. Want to make sure that you're in a degree mode, not radians. And then you're going to do pi. So I'm going to start pi divided by 4. But remember, this is a radian measurement, not a degree. So I'm going to go ahead and go to this little button right here. And I'm going to tell the calculator, hey, this is a radian mode, and put it in there. 45-degree angle, that's half of 90, which means your x and your y are exactly the same. Okay, so this is going to be a point on that system. Okay, here's another one that's a little bit different. This is going to be pi over 6. If we do that angle, I'm going to go ahead and just change this to a 6. You will see that that is actually 30 degrees. Okay, so I'm actually going to show you on a new piece of paper because it's a little bit different from your notes. Let me do it like this. Okay, so what we start off with here is we're going to start off with the equilateral triangle, which means that all the sides are exactly the same. Okay, just to be consistent, I'm going to use 2 on each of these. Okay, and I'll show you why. Remember, there's 180 degrees in a triangle. If I have 180 degrees and I divide it equally into 3 angles, each of these angles is going to be 60. Okay, so here we have 60 degrees and so forth. All of these angles match. Okay, now what I'm magically going to do is I'm going to say, you know what, let's cut this equilateral triangle in half. Once I cut it in half, this now becomes a 90-degree angle. Okay, this side is still 2, but what happens down here, if I cut it in half, this distance from here to here is now going to be 1. Okay, here's a 1. So now I'm going to take this triangle and I'm going to isolate it, and I'm just going to go ahead and do it like this. Okay, so now let's draw it out again. This is going to be still 60 degrees. This will now be 1. Okay, this is still going to be 2, and this is 90 degrees, which means this angle, the 60-degree angle, was also cut in half, making it 30 degrees. Okay, so now we have that. Can we find the distance of this point here? Well, yes, use Pythagoras identity. A squared plus b squared equals c squared. Let's plug it in. It's not the unit circle anymore, so we're not using c as 1. We're going to use c as 2. A will be 1. So we have 1 squared plus b squared equals 2 squared. Let's keep going. 1 plus b squared equals 4. So b squared is going to equal minus 1 on both sides, 3. Okay, but it's squared and we just want b. So b is going to be equal to, if you take the square root of both sides, hopefully remember that it's going to be a plus or minus the square root of 3. This is going to be important when we actually get to our unit circle, but we're going to assign it to positive 3 right now. Okay, we're going to assign it a positive square root of 3 in this case. Let's go back to our paper here. Here we go. If I'm looking at this angle, this is exactly what I do. Now, I know it looks slightly different from mine. And what I'm going to do is add here square root of 3. But look at what happens. Let me pull this out just a little bit. Look at what happens so that they do look identical. Is that our angle here is 30 degrees and our angle here is 30 degrees. So what I'm going to do is I'm going to label this point A and point B, and I'm going to flip it so it's exactly the same side as what we're showing here. So now I'm going to flip it and it's going to look like this. My 90 degrees is going to be here, where it is right here. That's going to be our point C. This point is going to be here. So that has to be B, and this is going to be A. And all I'm going to do is translate all the points. This is still C. So from B to C, that's the square root of 3. From A to C, that's going to be our 1. And from A to B, that's going to be 2. Okay? And angle B is 30, so now we have 30 degrees here. So now these two triangles match. How do I get where the sides will match? Well, divide everything by 2. If I divide everything by 2, you see the square, 2 divided by 2 is the same thing as 1. That matches. 1/2, square root of 3 over 2. It matches. Okay, the only difference is the 30 degrees is the same thing as the pi over 6. One's in degree form, the other is in radian form. Okay. Here's our unit circle. Here's 30 degrees. Notice that when I'm looking at the regular triangle like I did here, the other one is 60 degrees, which is right here. Okay, so if I'm looking at this point and I'm saying, well, what is y? Y is going to be the square root of 3. What's x? That's going to be the 1. So if I'm looking at 60 degrees, x is going to be the 1, which is up here. And then the y is the square root of 3, which is right there. So if you see here, that matches. This is x, this is y. Okay. So here's the really cool thing about this. When we're looking at these specific angles, I'm going to start with the 45-degree angle. I'm going to draw a line here, and I'm going to draw a line here. Okay. Notice that this angle from here to here is going to be 45 degrees. Okay. The angle from your pink line here to the x-axis is also 45 degrees. If you don't believe me, just go ahead and take the 180 and subtract the 135. You get a 45-degree angle. What about here? Okay. This is also going to be 45 degrees, but in the negative direction. See? Okay, so here's going up, here's going down. The angle is 45 degrees, the direction's going down. Same thing right here, 45 degrees. Okay, so you can take 225, subtract the 180, you get 45-degree difference. Okay, here's the thing that you need to look at. Look at our x and y values. They are exactly the same. Now, the only difference is the negative is on here. But remember, on a quadrant, in our quadrant, first quadrant, both our x and our y are both positive. In quadrant 2, x is going to be negative, y will be positive. Look at down here. Okay? Same exact values. But in quadrant 3, it's going to be negative x, negative y. Quadrant 4, positive x, negative y. So when we go back and say, remember we said it could be a plus or minus square root of 3? In some quadrants, and in fact, in 2 of the quadrants, it's positive. In the other 2, it's negative. In these 2 quadrants right here, look at our y. They're both positive. Okay? If we go down over here, our y's are going to be, let me see, these 2, they're both negative. Let's look at our x's here. Our x's here and here, 2 of them are positive. If we go on to the other side, our x's on these 2 quadrants are negative. This is going to be really helpful when we're starting to talk about is sine or cosine. Remember, cosine is our x. Cosine will be positive in 2 quadrants. Sine is going to be negative in 2 quadrants because those are our y's. Okay, so that's going to be really helpful and important later on. Little tricks. Okay, so all of these are exactly the same. Well, guess what's going to happen for the other parts? Other parts are going to be the same. These 2 angles right here, 30 degrees. Okay, notice it's a different color, but I'm going to go ahead and do a thicker line. And this one right here is also 30 degrees. 210 minus 180 is 30 degrees. Notice again our x and our y values match except for the positive and negative signs. It depends on which quadrant you're in. 30 degrees right here, 180 minus 150, that's 30 degrees. Okay, and then over here as well. 360 minus 330, that's 30 degrees. So here's going to be another 30 degrees. Okay, all of these values also match. Okay, so keep that in mind. That's going to be really, really helpful. Of course, if those match, so are going to be for the 60. It's going to be my other color. Okay, this is 60 degrees from here to here. I'm going to do it a little bit different, a little bit wider. Here's 60 degrees. Okay, and then we have another 60 degrees here and another 60 degrees there. It's negative and positive 1/2. And then the y's are the same. And if I look over here, you have a negative and positive of your x. Both of the y's are negative here. So those are going to be the same. Our other points, which are often forgotten, are just going to be on your x or y axis. So here you're going to have go forward 1, you're not going up or down. Up only, not going forward or back, it's 0, up 1. 0, down 1, negative 1. Back, negative 1, and you're not going up or down, so that stays at 0. Okay, so this is a really, really nice circle. The other thing that you can see, and if you watch the video, you will notice that there's a pattern here. 0, 1 in the numerator, 2 in the numerator, 3 in the numerator. Now I know you're saying, well, this is not a 4, but if we take all of these and we say, well, let's look at it being at the square root of 4 over 2. What's the square root of 4? Well, that's 2. 2 over 2, that's your 1. Okay, so 0, 1, 2, 3. Square root of 4 over 2, that equates to 1. So this is a really nice, neat little package on how the unit circle is used. It is the biggest thing that you should know how to use and know how to read. We're going to be using it for lots of information, and this is just the start of it. Okay. All right, so what this is basically saying is identify the ordered pair on the unit circle that corresponds to this angle in radians. Then it wants us to evaluate your sine and your secant. So let's start with finding it on the unit circle. I'm going to be using the bigger unit circle and not the one that I just colored up. I'm going to be using this one. And we're going to go to 5 pi over 3, and we're just going to look for it over here, and there it is, 5 pi over 3. Let's go back and evaluate. What is sine t and secant t? Well, let's start with sine. If you remember, and you need to remember, sine is the same thing as your y. So all I'm going to do is go to my unit circle and say, if I'm looking for sine, I'm going to look for the y value, and that's going to be equivalent. So sine of t, t is going to be equal to that t, so I'm going to fill that in. I'm going to say sine of 5 pi over 3, and I'm going to list the ratio it's equivalent to, which is in this case negative square root of 3 over 2. Okay. Then it wants us to do secant. So here's the part that you have to remember. If we go back and look, and this information you're not going to get, any of the information that's not on your unit circle, you're not going to get. So you're not going to get this information. But if we're looking for secant, remember that's the same thing as 1 over cosine. So if you remember what cosine is, hopefully you remember cosine is the same thing as x. All you're going to do is look for the x value and take the reciprocal of it. Or in other words, flip it. So I'm going to go back to my page here, and I'm going to say, okay, 5 pi over 3, 5 pi over 3, this is my x value. So all you're going to do for secant, let's go in right here, secant, 5 pi over 3, is I'm going to take the x value and take the reciprocal. So what is the reciprocal of 1 over 2? Flip it. It'll be 2 over 1, but all you need to do is write it as 2. Okay, it's understood that there's a 1 underneath there. That's it. That's your answer. So by you looking at the unit circle, you should be able to answer all 6 trig functions just by looking. Okay, if it is on the unit circle. We're going to be doing some that are not on the unit circle in the future. Okay, let's go ahead and do this one. Evaluate cosine and tangent for t is equal to negative 5 pi over 6. Okay, so be careful here. There's a few things you need to keep in mind, all right? Number 1, this is not a standard angle. Remember, a standard angle is anything from 0 to 2 pi when we're looking at radians. But if you're going to go to the unit circle, do I want to go to the unit circle and say, oh, well, here it is. I'm just going to go down. No. 5 pi over 6 is the same thing as 150 degrees. So if you're negative, you're going down 160 degrees. So what you can do is you can take this angle and add 2 pi, or you can just take it and go 150 degrees in the opposite direction. I'm going to go ahead and start with this angle here, and I'm going to say negative 5 divided by 6. Remember, you don't need to include the pi because it's an irrational number, and all I'm going to do is add 2. That's where we did in the previous video. And now we get this number. So let's go ahead and convert that to an improper fraction, second PRB, and then second under the one under PRB. And that's going to say that's the same thing as 7 over 6. So now I can look at the unit circle and say, oh, okay, yeah, here's 7 over 6 pi. So in the other video, in the other question, it said 5 pi over 6. Let's count. 1, 2, 3, 4, 5, 6, 7. It took 7 lines to get to 5 pi over 6. But that's for positive. So if I'm going to go negative 5 pi over 6, I need to go down 7 lines. 1, 2, 3, 4, 5, 6, 7. There it is. Or, like I did it earlier, use the calculator and just add the 2 pi to your negative value and then convert it to an improper fraction. So now that I know that this value is the same thing as 7 pi over 6, I'm going to write it like that. I'm going to say, okay, cosine of negative 5 pi over 6 is the same answer as cosine 7 pi over 6. How did I get from here to here? I added 2 pi. Okay, added 2 pi. Now, cosine. Cosine is our x or is it our y? Hopefully you said it was your x value, so our answer is going to be negative square root of 3 over 2. Okay. All right, and it's also asking for tangent, so let's go ahead and put that. Tangent, negative 5 pi over 6 is equal to tangent 7 pi over 6, which is equal to, and remember tangent is of t is equal to TOA, opposite over adjacent. Opposite is going to be our y, adjacent will be our x. So tangent is y over x. So I'm going to go to my unit circle again, and I'm going to look at that value that I have. And instead of doing all the complex fraction like I did before, I'm going to look at the y value, put it in the numerator, and the x value, and put it in the denominator. But denominators match, so I don't have to include those. It's going to be negative 1 divided by the negative square root of 3. Negative 1 over negative square root of 3. Now, our two negatives will cancel, and you'll have positive 1 over the square root of 3, but we never keep it in this form. Go ahead and rationalize your denominator, and it's going to be the square root of 3 over 3. This will be the answer for this second part for tangent. So this is going to be an important part, but we're not going to go into too much detail now because you'll get a lot of explanation on this, especially when we're doing our graphing section. So you'll see a lot of this repeated in the next section. But I am going to go ahead and go through it. Remember earlier I was talking about y and x, sine and cosine. If you look at that very first page, I was saying, oh, there's no restrictions. And if you remember in college algebra, we have no restrictions means that x and y can be whatever they want. So we don't have any restrictions for x and your y, or in other words for sine and cosine. The other restrictions we had here, we said x couldn't be equal to 0 because then it will cause it to be undefined. So if I'm looking at my graph here, x is going to be 0 up here, x is going to be 0, and down here, x would be 0. Okay, so the tangent and your secant functions are undefined at those values. Okay, they're undefined at those values. When y is equal to 0, you're going to have undefined values for cotangent and cosecant. Okay, so you're going to have values for everything except when y is equal to 0 at this value here and this value here. Okay, that's what this is basically saying. Okay, so here, our domain, all real numbers, no restrictions. Okay, here it looks a little bit different, but I'm going to show you what this means. It's saying excluding the odd multiples of pi over 2. So if we use n as 0, you would have pi over 2. Okay? So if I look at pi over 2, that's right here. That's going to be for tangent and secant. Well, that says tangent and secant. If we go to 1, it would be 2 plus 1, which is 3 pi over 2. Well, where's 3 pi over 2? Right there. Again, tangent and secant. Those are going to be our restrictions, our domain. Okay. For cotangent and cosecant, all we're doing is finding the multiples. So if n is 0, it would be here. If n is 1, it would be 1 pi. If n is 2, it would be 2 pi. And you're going between these two values, which makes cotangent and cosecant undefined in those specific areas. Okay, all of this information I already kind of went through. Pythagorean's identities are over here. I'm going to show you how we can go to from one and get the other two. We'll do that a little bit later. But all of this stuff right here, you must know. It is imperative that you have this solid foundation on your reciprocals and your quotient identities to be successful in the rest of the course. Okay, so don't wait to learn this. Go ahead and learn it now. It'll make your life easier. Let's go ahead and go on to the next part. All right. Given your sine and your cosine, use a reciprocal and quotient identities to find tangent and cosecant. All right, let's start with tangent. So I'm going to do tangent t. Remember, tangent is opposite, or y, over x. Okay, y is going to be our sine. So this is the same thing as saying y. Cosine is going to be the same thing as saying our x. So all I'm going to do is go ahead and say, well, tangent, denominators are the same, so all you're looking at really is the numerators. What's our y? 15. What's our x? 8. You're done. Okay? It really is that simple, but you have to remember some of the basic principles. If we go to cosecant, okay, you have to remember cosecant is the reciprocal of sine. So all I'm going to do is look at sine here, and I'm going to flip the numbers. This would be 17 over 15, and you're done. Okay? So one of the easiest ways that I remembered this was cosecant is a reciprocal of sine. Secant is the reciprocal of cosine. So if you have a C, the reciprocal is the S. If you have an S, your reciprocal is the C. Cotangent and tangent they both are the only ones that have a T in it. So those are both really easy to remember. And then all of these you're going to get more familiar as we go. Okay, so I'll help you with that as we go through. All right, go ahead and let's try this one. We have secant. Now it's telling us some specific information. It's actually giving us a quadrant we have to look through. So it says, given the sequent for this. Well, which quadrant are we in? If we're between 3 pi over 2 and 2 pi, that means we're going to be in quadrant 4. Okay, so here's our quadrant. All I'm going to do is draw our picture. Okay, so the angle here is going to be this one right there. Okay, so that's the angle that we're talking about. Now I'm going to say, well, secant is the reciprocal of cosine. So cosine of t is equal to 3 over the square root of 11. Okay, if you remember using Pythagorean's identities, cosine is going to be x over r. Okay, so let's do the r over here, square root of 11. Our x is going to be 3. Can we find our y value? Yes. Now, this is really important. Notice that if we're in quadrant 4, y has to be negative. So you can't forget those negative signs because it's going to make a difference. All right, let's go ahead and do this one. Okay, I have a squared plus b squared equal to c squared. Okay, c squared is 11, the square root of 11, which is squared. A squared is 3 squared plus b squared, same thing as y. Okay, so let's go ahead and do this. 9 plus b squared is equal to 11. So b squared is equal to, subtract 9 from both sides, you get 2. So So b has to be a plus or minus square root of 2. But like I said, you notice here it's going in a downward direction. B has to be negative. So I'm going to say b is equal to negative square root of 2. So I'm going to go ahead and put that here, negative square root of 2. So what is tangent of t? Well, tangent of t is going to be opposite, which is here, over adjacent. So I'm going to say negative square root of 2 over 3. Okay? Negative square root of 2 over 3. Okay. All right. So that is how you're going to be doing this one. It's going to be really, really, really super important that you make sure to go ahead and include your quadrant that you're in, because if not, your tangents will be incorrectly written. All right, let's go ahead and go on to the next one. All right, so this part also, I'm going to go ahead and just briefly explain to you, but I'm also going to tell you that we're going to be testing a lot on this in the next section. So even though you may not understand it, you will by the next section, okay? The next unit, not the next section, the next unit. All right, so all of these trig functions that we have, everything is going to have a specific period. The period means it's when it starts to when it finishes. So if we look at the unit circle, and let's look at the value sine. Remember, sine is your y value. Here's where it starts at 0, and then it's going through here. Y is 1, and then we'll keep going, 0 again. Now, these values are slightly different than some of these other values, so we're going to go through the entire thing. That's one whole rotation, which is also referred to as your period. Okay, so when you go through the entire cycle once, that's the period. So it's saying sine, cosine, cosecant, and secant. These all have a period of 2 pi. Okay. When we come to tangent and cotangent, the period is only pi. Okay. I'm going to explain why the periods are like that for tangent and cotangent more in the next section. But let's go ahead and do this one. It says use the unit circle and the period of the function to evaluate the expression if possible. All right. So here, remember I was telling you we could add 2 pi. 2 pi would give us a coterminal angle outside. So remember that this is not a standard angle. How would we get this angle to a standard angle? By adding your 2 pi. So basically, if you look at it that way, that's all we're doing here. So let's go ahead and do that. We're going to say cosine of negative 7 pi over 4 plus 2 pi. Let's go ahead and evaluate that and see what it comes out to. I'm going to go ahead and do it here. I'm going to do negative 7 divided by 4. Remember, I don't include the pi in this case. And I'm going to add 2. And then I'm going to see that that's equal to 0.25 or 1/4. So here, this is going to be cosine of pi over 4. Okay, now I can use the unit circle, and this is why it comes into handy, because I don't have a negative 7 pi over 4 on my unit circle, but I definitely have a pi over 4, which is right here. And what is cosine of pi over 4? Cosine is going to be your x value, so that's going to be the square root of 2 over 2. So the square root of 2 over 2. That's going to be our answer. Let's go ahead and do the next one here. Okay, tangent, tangent negative pi over 2. Now, yes, you can add 1 pi because that includes the period, but you could also keep it as 2 pi, and that's not going to change your answer. It does make it a little bit easier if you are having problems remembering what your periods are, at least for right now. When we go into the next unit, which is graphing these trig functions, you will definitely need to know that tangent and cotangent has a period of pi. I'm going to go ahead and do 1 pi, but if you get 2 pi, you'll get the exact same answer, and I'll do that underneath. So negative 1/2 plus a positive 1/2 makes it a positive pi over 2. Okay, so positive pi over 2, what is tangent? Let's go to our unit circle. Here's pi over 2. Tangent is y over x, so it would be 1 over 0. 1 over 0, which is undefined. Okay, undefined. Let's go ahead and do it where if we added 2 pi. Let's see how that, if it would change our answer. So negative pi over 2 plus 2 pi, if you wanted to keep it like that. Let's go ahead and figure out what that would be. I'm going to go ahead and do it in the calculator. Negative, you get 1.5. 1.5 is the same thing as 3 pi over 2. Okay, so if I go back to the unit circle, there's my 3 pi over 2. It's still going to be tangent, which is y over x, but this time it's going to be negative 1 over 0. Well, anything over 0 is going to be undefined. So you get the exact same answer using either one of the methods. This is the actual distance or the length of the period for tangent and for cotangent. But this would also work because what you're doing is you're going exactly one entire rotation. So both of these work, okay? And it'll be up to you which method you prefer to do. All right, next page. Okay, we're going to do some more over here. Here, notice that this is greater than 2. So what I'm going to want to do here is subtract. I know that this is greater than 2 because 6 times 2 is 12, and the 17 is definitely larger than 12. So I'm going to start with the 17 divided by 6, and I'm going to subtract 2. So now I get this value. So I'm going to write down the steps here for those who are not watching the video so they can see. Okay, and then I'm going to go ahead and convert this into to a fraction, and I get sine of 5 pi over 6. Sine, remember, is your y value. Let's go over here. Sine 5 pi over 6 is right here. Sine is going to be our y, which is 1/2. So this answer here is going to just be 1/2. Okay. The next one we're going to do, same value. So I'm going to skip the actual work and just say, well, this is the same thing as secant of 5 pi over 6. Remember, secant is the same thing as 1 over cosine 5 pi over 6. Okay, so if I know cosine, I'm going to say that's going to be our x. So I'm going to take this value and I'm going to flip it. So here we're going to have negative 2 over the square root of 3. Never ever leave it non-rationalized. Go ahead and rationalize the denominator. Sorry, so for in this case you'll have negative 2 square root of 3 over 3. Alright, so what I'm going to do here is I'm going to subtract the 2 pi, so cotangent 7 pi over 3 minus 2 pi, and again I knew it was more because if I double the 3 I get 6, and this is more, so I'm going to have to subtract. Let's go ahead and use the calculator for that one. So 7/3 minus 2 gets me this value. Convert it to a fraction and I get 1/3. That's between 0 and 2, which is good. So I want cotangent of pi over 3. So let's go ahead and go on to the unit circle. Pi over 3, cotangent is going to be our x over our y. Tangent is y over x, cotangent is x over y, so I'm going to have 1 over the square root of 3. Rationalize that denominator, you get the square root of 3 over 3. Okay, next one is 3 pi. Obviously that's more than 2, so I'm going to subtract 3 pi minus 2 pi, and I'm going to use cosecant of pi. Other note I want you to notice, as I did use 2 pi, you don't have to use 2 pi, you can use the 1 pi. So either way you would have gotten the same answer. Okay, go back to this one. We have cosecant of pi. Here's our pi. Cosecant is the reciprocal of sine. Remember, if it starts with a C, the reciprocal is with the S. So here's our S. And if I were to flip it, think of this being over 1, it would be 1 over 0. So this would be 1 over 0. And anything with a 0 in the denominator is going to be undefined. Okay, so that's going to be undefined. These kinds of questions are going to be really important for you to get down, because if you don't get it down now, you're going to be struggling throughout the entire semester. Okay, the next section, which we're almost done, is going to be talking about odd and even functions. We are actually going to talk a lot more about this when we start graphing them. So I'm going to kind of go over it a little bit more in detail then, but for now I need you to just memorize that your cosine and your secant are even functions. Everything else is going to be odd. So there's not going to be neither. It's going to be cosine and secant are even. These are reciprocals of each other. Okay? These are odd functions. We'll talk more about that next time. Okay, so if I'm looking at these here, it's just saying use the properties of the trig functions to simplify. So that's all we're going to do, is we're going to simplify this. Okay, so t plus pi. Well, if you remember, pi for tangent is 1 period. So it's basically the same thing as saying tangent t. Cosine, if I add a 2 pi to t, it's like saying, it's the same thing as saying cosine t. Okay? So all we're doing here is simplifying it like that. The next thing we want to do is break it down just a little bit more. What is tangent referred to? Well, tangent is sine t over cosine t times cosine t over 1. Cosines will cancel and you're left with just sine t. In this case here, don't let the 2 pi scare you. You can just remove it because it's the same thing as saying sine. So I'm just going to take it out and you're left with the negative t. This is where you need to go back and say, is sine a odd or an even function? Well, sine is going to be your odd function, which means the t does affect your sine. It will actually, this negative will actually come out. So I'm going to have a 3 sine t minus sine positive t. Let's go back to that other page real quick and I'll show you what I mean. Here, if sine has a negative t in the inside, all you're doing is pulling that negative out. Okay, so that's all we're doing here. So what is 3 minus 1? Well, that's just going to be 2 sine t. Okay, all we're doing on these is simplifying. Okay, next one, sine, negative, pull it out, negative sine t. Secant, what is secant? That's a reciprocal. That's the same thing as saying 1 over cosine t. Okay, and then a negative and a negative, tangent is an odd function, so this negative gets pulled out to the front, making it a plus tangent t. Okay, so pull this out to the front, and then a negative times a negative gets me a positive. So let's just look here. What is sine over cosine? Well, sine over cosine is the same thing as tangent. So it's a negative tangent plus a positive tangent. So a negative plus a positive, well, that's just 0. Okay, because they cancel each other out. All right, last 2 problems here. The first one says, oh, okay, now we're using a calculator. So this is going to be actually a lot easier. If we look at these trig functions, we'll notice that you have to look at your theta. In this case, theta does not have a degree sign, so it's telling us that these two are going to be in radian form. So first thing I want to do is make sure that I'm in radian form. Okay, if you're on the wrong mode, you're going to get the incorrect answer. So all you're going to do is go ahead and type cosine 7.482, and there's your answer. Okay, it's really that simple, but you will get it wrong if you're in the incorrect mode. I'm going to go ahead and write the answer here, but then I'm going to change it to degrees, and you'll see what I mean. So this is going to be approximately 0.363. 4 decimal places. This is a 4, but this is a 6, so this changed the 4 to a 5. So this will be 5. Okay, let's see what happens if I had it in the wrong mode. If I kept it in degree mode, notice that this value will be completely different. Okay, so make sure you're in the correct mode. Let me go ahead and change that back to radians. Okay, and then now I'm going to do this one. Now, here's the problem with this one. Notice that we don't have a function with cosecant on it. We do have inverses, but this is going to be completely different, and these are not the same as this, okay? So don't use the exact same key. The reciprocal of cosecant is sine. So this is the same thing as saying 1 over sine 2 pi over 5, okay? Write it out like this, and then we can go ahead and put it in the calculator. I'm going to do 1 divided by parentheses sine 2 pi divided by 5, and then I'm going to close it with 2 parentheses. The first one closes the angle, the second one closes the denominator. Press enter, and there is your answer. It's going to be approximately 1.051. Again, this is a 4, but the next one over says it's a 6, so this is going to change to a 5. So it'll be 1.5. Okay, that's how you're going to evaluate using the calculator and rounding to 4 decimal places. These angles here, not on the unit circle, so it's a lot harder to evaluate those without a calculator. All right, that concludes 4.2. I know these first 2 sections were really, really long. It is mostly the basics of what we're going to be doing throughout the course, and it is definitely the most vital information that you need to know.